Hi guys, this is a video to go over your homework. And so let's start with number 15. I had a couple questions from you guys of this number and I see why that is. So we need to think about a couple of things here if you read the question. For example, the principal is $10,000. Which is easy to see from the question. But what we have to realize is that here, the year 2003 was basically year 0. Does that make sense? Because that's when I put the money in. And then the time has passed and it became 2015 and my money has become $16,960. So we need to figure out how many years has passed. Well, from 2003 to 2015, that's 12 years. So then we need to plug it into our formula. So it's A equal P times 1 plus NT. However, here, N isn't really specified, right? So in this case, we are going to assume N to be annually, meaning 1. So I'm going to plug in all the numbers that I know. So it has become equation for R, because we have no idea what R would be. So the first step of finding R is that we divide both sides by 10,000. And then 12, it's power of 12. So what you can do is I'm going to write it up here. You can do 1/12 power to get rid of the power of 12. And I have 1 plus R here. And then after that, we just subtract 1 from both. So I'm going to plug it into my calculator to figure out what the left side number is. And it's 1.045-ish. So then I subtract 1 from both sides. So then R is just 0.045. So that's why you see a equation, the answer as 10,000 times 1.045 to the x power. Basically what they used was that they assumed n to be 1, and instead of t, they use x because they said write the function in terms of x. So once you have that equation, the rest of it is just plugging in the number for part B. It says what is the account in 2025. So that's now when the time is 10 more than 2015, right? So instead of x from the first equation, you plug in 22. Then you get about this number. Okay, let's move to number 21. It says determine how much is in a retirement account after 12 years if 5,000 was invested. So P was the initial amount, right? And then time has passed 20 years and the interest rate was 0.0605 because we talked about how we write the interest rate in decimal. And we need to figure out what N is, and weekly we assume 52 weeks. So then we just plug it in to our formula, the compound interest formula, over N, and N times T. I'll plug it in to the calculator. If you are not using the parentheses correctly on a calculator, you might also get a wrong answer. So make sure you have a good habit of using parentheses. And I got the same answer as the book answer. So let's go to 23. It says a college savings account pays 13.2% annual interest, compounds semi-annually, meaning that it compounds twice a year. What is the balance of the account after 12 years if my initial amount was this? Again, this is a compound interest formula, so we plug in everything that we know. 1 plus 0.132 over 2 times 12. And if I plug it in correctly, I get the same answer as the book answer. The calculator actually gives you 0.6099, and since you have to round up to the nearest cents, that's why we have 0.61 as an answer. Okay. Number 19. A virus is spreading through a computer network according to the formula. So they gave us the formula. 30 times e to the 0.1t. And v is the number of computer infected, and t is time in minutes. And it's asking you how long will it take the virus to infect 10,000 computers. So this has to equal 10,000. So we solve it by dividing both sides by 30. Then I have e to the 0.1 t power, and the other side is this. Well, our goal is to get the t, and at this point, you can't get a t unless you use a logarithm, right? So we use ln. And because this is a power, it comes out. And what did I say about the same base and the same thing inside? This becomes 1. That's equal to 1. So to find t, we need to divide each side by 0.1. So this thing divided by 0.1 is your answer. So t is about 58.1. So this one, yeah, so that's why the answer is about 58 minutes, because t was time in minutes. Alright, I'm not going to do 40 since I made another video about 40, so let's just do 47, which is the last question of this homework. It says use a formula for continuously compounded interest. So if you don't remember the formula, it was the part. Sorry. R and T is the power of the E. It says if you deposited $800 in an account paying 4.5 interest compounded continuously, how much money would you have in 5 years? So if you plug all of them in, you should get $1,001.86. And it says, how long would it take you to double your money? You could assume that, excuse me, the number is the same as A. Well, another way to look at the part B is this. If I have P of 1, and then doubling would be that A is equal to 2, right? And assuming that the rate stays the same as part A, all I need to do is plug in 0.045 here. And I have to use log to bring the t down, right? So it's very similar to what we just did in the previous problem. So let me just again, this becomes multiplication. And then ln e is 1, so I'm not going to write that. And then to find t, we need to divide both sides by 0.045. And that should give you about 15.4 years. Alright, if you want to double your money in 9 years, what rate would you need? So this one is similar to B, but the question is asking for rate, not time. But the setup is very similar. So let's see. So you want to double, so A is 2, P is 1, so I'm going to skip that. E to the, I don't know what R is, but I want to make sure that it happens in 9 years. Okay, so do you see how the setup is super similar? So then we, again, take natural log to each side, and then 9R ln E. Do you see how I'm continuing to skip? So this becomes 1, and then divided by 9. So R has to equal about, it will probably give you 0.077. That's why the answer says about 7.7%. Okay, so if you just write 0.077, that's fine too. Last question. If you want to open an account that pays 4.75% interest compounded continuously and have 10,000 in the account 12 years after your deposit, how much would you need to deposit? So now this is asking for P. Okay, let me do that with green. All right, so P we have no idea, but E, and it's 0.0475 because it's my rate, and in 12 years T, and I want to have 10,000. And then, sorry, this one is actually quite simple because this whole thing is a number. Because E is a number, so if you plug in everything in the calculator, and if you divide both sides by that number, then you'll get P about that amount right here. Okay, so I hope that wasn't too challenging. And I think number 15 would have been the most challenging one because it wasn't really specifying what n would be and things like that. And so other than that, I think you guys would have done okay. Okay, and I will see you tomorrow with the lesson video.